Welcome everyone. In this video lecture, we will solve a rectifier circuit problem. Okay, so this problem is from the Microelectronics circuit book. So the question is a half wave rectifier circuit with a 1 kilo ohm load, okay, operates from a 120 volt RMS household supply. So basically this one is our transformer. So we are giving the primary voltage, this one 120 volt RMS 60 hertz. So with a turn ratio 10 is to 1 step down transformer. So it uses a silicon diode that can be modeled with a zero point 0.7 volt drop. Okay, so we have to find out what is the peak voltage of the rectifier output. We have to find the peak voltage of the rectifier output. Okay, and the fraction of the cycle does the diode conduct. Okay, fraction of the does cycle does the diode conduct, and what is the average output voltage and the average current in the load. These four things we have to find. Okay, first the rectified output, second one is the fractional fraction of cycle does the diode conduct, and average output voltage and the average current in the load. Okay, so four things. So first of all, this one is our center tape transformer with 10 is to 1 ratio, primary side 10 1. So first of all we have to find out the secondary voltage Vs. So this Vs can be find out. Okay, I have to select pencil. This Vs, the secondary side voltage, this one Vs will be Vp. I am saying this voltage is our Vp. Okay, Vp times N2 by N1. Okay, so Vp we can simply write 120 volt RMS value with N2 turn ratio 1 by 10. So this one is simply our 12 volt RMS. So 12 volt RMS is the secondary side voltage. So if we have to find the peak, V secondary peak, I am saying we have to just 12 root 2 volt. Okay, this one will be the peak output, peak input voltage. Okay, at this secondary side, this Vs. So now we have to concern about this Vs. So what exactly we are giving input to the diode is just simply our Vs. Our primary concern is now Vs with time t. So we are saying we are giving some sinusoidal signal. So the expression for this one can be written at 12 root 2 sine theta. Okay, like that we can write. Clear? So or t, or better to write theta. Okay, so then after this input waveform will be like this. Okay, first cycle. So in radian if we write, we can write it pi 2 pi. Okay, this one is the inputs one, input voltage across the secondary side, and this peak is nothing but simply 12 root 2, and the another one is this minus 12 root 2. Now we have to draw the output waveform. Okay, so before that, in our earlier video also we have covered up the this diode uses a voltage drop, quotient voltage drop 0.7 volt. Okay, so we have to find the transition voltage. So there is a concept of transition voltage. This transition voltage, every time we are finding in case of rectifier, and in addition to also clipper circuit, to identify the reference line, we are identify the reference line. After what, the diode conduct. Okay, this transition voltage we are finding, where it will say where the diode conduction when current is 0 in the circuit. When diode is just on and the current in the circuit 0. Okay. So for this thing, I am just once again I am making the same circuit. Okay, so this one is Vs and this is zero point 0.7 volt. Okay, R diode just on, so the current will be 0. So Vs minus 0.7 equals to 0. If we apply KVL in this loop, say loop 1, so Vs equals to 0.7 volt with the reference line. So this is every time I am calculating, you can also say directly when the voltage Vs will be greater than 0.7 volt, the diode on. When Vs less than plus 0.7 volt plus 0, diode off. Okay. To find this condition, we have to first draw this reference line Vs equals to 0.7. So that 0.7 line will be somehow like this. Vs. So that's why every time I am just finding this reference point, okay, or transition voltage, okay, in which diode just on and the current in the circuit will be 0. So okay, so Vs plus Vs minus 0.7. Then we have to plot this line on the input waveform. So now we have to decide above this point Vs greater than diode is on or off. So Vs greater than 0.7, okay, diode will be on. Okay, this will we will write plus minus 0.7 volt. Okay, this is my mistake, plus minus 0.7. So above this diode will be on, simple on. Okay, like 1 volt, so diode will be on. Okay, below 0.7 like 0.7 below like 0.6, so diode will not on. Okay, and below this line diode will be off. Is it clear? Means if this voltage is less than this, okay, so this diode will be not conduct. So diode on only above this point. Okay, so diode on, so you can also directly we can write, but this is the way how to do. Now we have to draw the output waveform first. So output waveform, so these are intersecting at this point. Okay, so I am saying this point as a T1 point and T2 point. Okay, or we can say theta, better to write theta. This point say theta point, and this point, okay, this point is pi minus theta point. Okay, another point we are not interested too much. Okay, so this one is okay pi, sorry, theta, and this. So this can be easily find by just writing an equation like 12 root 2 sine theta equals to 0.7. This curve, okay, this curve, that is our Vs 12 root 2 sine theta and 0.7. If we just calculate this one, it will come 0.7 by 12 root 2. So it will give the intersection point, this point, theta and this. So first 0.7 divided by 12 root 2. If we do, it will come nearly 0.0412. I have already calculated, so I am writing. So theta equals to sine inverse 0.0412, and we have to write in the radian 0.042. Okay, it is in the radian because we are dealing with the radian 1 by 2 pi or something, so better to write in radian. So theta equals to 0.042. So now this point, this theta value, we have already find out 0.042 radian. Okay, now we have to find the conduction angle for the period 0 to 2 pi. The conduction angle will be theta minus pi minus theta. So this distance theta to pi minus theta. Okay, so it should be simply, okay, conduction angle. Okay, once again, okay, first I have to show in this graph conduction angle is only this point. Okay, so this conduction total conduction angle will be this distance minus this. Okay, so you have to write a pi minus theta minus theta. Okay, so it should be pi minus 2 theta. So conduction angle will be pi minus 2 into 0.042. Okay, so if we solve, so this one we have to write 3.14 minus 0.084, so it will come nearly 3.06. And if we solve this one, it will come 3.06 radian conduction angle. Okay, clear? This conduction angle is very important. In this case only, what we have to write, this point pi minus theta. Okay, so this much distance, so this is our 3.06. Okay, so now output peak voltage. So for output peak voltage, the first thing, peak peak voltage or peak rectified output voltage. So now what we have to do for the peak output voltage, you can say also, or rectified output, anything you can say. So the peak output voltage we have to find. So from this graph, okay, I'm just making a simple plus minus Vs. This drop is 0.7 volt, and this one is our V naught. So when diode on will give the peak rectified output voltage. So one can write plus Vs minus 0.7 minus V naught equals to 0. So V naught equals to Vs minus 0.7. So this one is the peak rectified output voltage. So Vs we have to take a 24, sorry, Vs we have to write as, this one is uh, means 12 root 2. Okay, so 12 root 2, Vs will be our 12 root 2 peak value minus 0.7. So if we solve, this will come 12 root 2 around 16.97 if we calculate. Okay, so this value will be 16.227, I think. Okay, so it will come like 16.27 V naught peak. Okay, this one is a peak output. So 16.27. Okay, and this Vs equals to V naught plus 0.7. Okay, the Vs is V naught plus 0.7. So V naught is simply, we have already written. Okay, Vs minus 0.7. So this value V naught equals to Vs minus 0.7 is the expression for the output voltage when diode conducts. So we have already calculated. So now when Vs equals to 0, or when Vs equals to 0.7 volt, the V naught will be 0.7 minus 0.7, means 0 volt. Why I am doing? Because at this point the output voltage will be 0. At this point the output voltage will be 0, and it will go maximum peak at pi by 2 will be 12 root 2 minus 0.7. So the output waveform will be somehow like this. Okay, sinusoidal signal. And for the other thing, it is below this one, it is below. Okay, so this one is the output voltage, and this peak we have already calculated. This peak is 12 root 2 minus 0.7, or after solving it is coming 16.27. volt. Okay, so this is the 12 root 2 minus 0.7 means 16.27 volt came. Okay, so this is the output peak and this is the output waveform. Now we have to find out the diode conduct means, or for what fraction the diode conduct. The third part, for what fractions the diode conduct means diode conduction for what fraction. Okay, so here we can easily say in a 2 pi radian, in a 2 pi radian, diode conducts for the 3.06 radian. Okay, means conduction angle is this one. So in 2 pi radian it conducts up to this one. So in 1 radian it will conduct 3.06 by 2 pi. So we have to find the fraction. So in 100 radian, what we can write, 3.06 by 2 pi. Simple unitary method, we have to apply 3.06 divided by 2 pi into 100. So if we solve this one, it will come 48.7%. Okay, 48.7% will be the fraction for the fraction of cycle, or we can say the, so there is also the fraction of cycle the diode conduct, fraction of cycle for the diode conduction, for the diode conduction. Okay, simple. This one is simple. So in a 2 pi radian, it will 3.06 radian. So in 100, this by using the unitary method. So now we have to find out the next one, the average voltage, average output voltage and average output current. The third point, average output voltage. So average output voltage, this should be the output voltage we have to find for the period 1 by 2 pi. So average output voltage we can find, but before that I want to means our output waveform we have already find. Okay, so this point is theta, pi minus theta, v naught, and say theta. So this point is our 12 root 2 minus 0.7. Okay, peak value. But for the sinusoidal waveform, v naught can be written as 12 root 2. I am writing as sine phi minus 0.7. Means 12 root 2 sine phi is like this. Okay, 12 root 2 sine phi. Okay, just I am saying some input signal source like this. Okay, then if minus 0.7, the this graph will be down and it will start like this. Okay, so this should be 12 root 2 sine phi minus 0.7. Okay, I am just moving. Okay, clear this one. So v naught can be written 12 root 2 sine phi. This one is the peak value, but we can write like this 12. Right? This one is the output voltage expression because we have to integrate. So average output, for the average output voltage, or we can say v naught average, we have to write the period of the signal 2 pi, and we have to integrate from theta to pi minus theta, and we can write as 12 root 2 sine phi minus 0.7 in bracket d phi. So not d theta, d phi, right? Is it okay? Means how to do this one, 12 root 2 sine phi, the sinusoidal minus 0.7, then it will down by peak value 12 root 2 minus 0.7. So this one is the expression. Okay, so now we have to solve this integral. For this integral, what we have to do, one can simply write 1 by 2 pi. Okay, and what we can do, better to write theta 2 pi minus theta 12 root 2 sin phi d phi minus integral theta to, we will go step by step, 0.7 d phi. Now we can easily solve this one. This should be 1 by 2 pi, and we can take 12 root 2 as a common, and after integral of sin phi is simply cos phi pi minus theta 2t theta minus 0.7. If we do this, so integral pi minus theta, or okay, d phi means your phi. Okay, then write one more line, phi minus theta to theta, integral, simple integral is there. So the value will be 1 by 2 pi 12 root 2. Okay, we can write it, take minus common. Okay, so one can write cos pi minus theta minus cos theta, okay, minus 0.7, okay, pi minus theta minus theta. Okay, so cos pi minus theta is minus cos pi minus theta is our minus cos theta. Okay, so minus cos theta minus 2 cos theta. So I am writing directly minus 12 root 2 into minus cos theta, it should be minus 2 cos theta, okay, minus 0.7 pi minus 2 theta. Okay, now we have to solve this. So okay, here I am writing 1 by 2 pi, then 24 root 2 cos theta minus 0.7 pi minus 2 theta. Okay, so what we, here I am doing this calculation here for V naught average. So what we can write, 1 by 2 pi and 24 root 2. Okay, so one can write 24 root 2 cos 0.042. Okay, we have already calculated the theta in radian, 0.042. Okay, I will show you. Theta we have calculated 0.042 radian, so we have written 0. And pi minus 2 theta also we have calculated the exact value of pi minus 2 theta. Okay, pi minus 2 theta 3.06 radian. Okay, so this can be written as minus 0.7 into 3.06. Okay, so this value will be 1 by 2 pi, and if we solve 24 root 2 cos 0.042 is somehow nearly 1. Okay, so it should be 24 root 2 minus 2.142 by 1 pi. If we solve this one, we will get 5.06 volt. So V naught average, we have 5.06 volt, and the final one we have to find the average output current. For the average output current, I am writing like I average equals to V naught average, output average voltage, by divided by the resistance. The resistance 1 kilo ohm. So 5.06 by 1 kilo means 10 to the minus 3. So it will go up. So 5.06 milliampere. So this one is the average output current. Average output current, V naught average, and this one is the average output voltage we have find out by using this expression. Okay, clear? So after a step by step procedure we can find. So the output waveform we know, average output waveform. So but the thing is that this waveform we have to know how to write. 12 root 2 sin phi is the sinusoidal waveform, but it is coming for, the peak is 12 root 2 minus 0.7. So first we have to do the 12 root 2 sin, then minus 0.7, then we have to solve. So like that we can solve this problem. So this is all about this problem. So thank you for watching this video.